Hi students, so this video goes over the drawing Lewis dot structures for molecules and polyatomic ions worksheet. I'm going to go through the answers for numbers 1 through 10, and you can check your answers for the written questions after the structures. So hopefully this video helps you learn to draw Lewis structures or clears up any confusions you have when you are doing this worksheet. So we'll start off with number 1, carbon. There's 1 carbon atom. There are 4 hydrogens. Total number of valence electrons. For carbon, we have 4. For hydrogen, we have 1. So 1 times, however, there are 4 hydrogens, so 1 times 4. It's a total of 8 valence electrons that we have to bond these atoms together. We're always going to put carbon in the middle. Okay, carbon is always going to be central. Hydrogen is always on the outside. Must be, because hydrogen can only single bond. It can only have 2 electrons in its outer shell. So we're first going to bond those atoms together, then we will check that all of these atoms are content, they're stable. So hydrogen is happy as long as it has a single bond. So each of these hydrogens is all done. The carbon here has 1, 2, 3, 4, 5, 6, 7, 8 electrons around itself because each bond contains 2 electrons. Sometimes people like to draw their structure using and showing the 2 dots like this. Okay, so that's another way to show a bond. These 2 dots between carbon and hydrogen indicate 2 electrons shared, and this is called a single bond. All right, so let's go on to the next one. Here we have H2O, which is water. Okay, so here the atoms in H2O, we have 2 hydrogens, and for oxygen, we have 1 of them because there's no number next to it. Let's add up the total valence electrons. For hydrogen, there is 1 valence electron, but we have 2 hydrogens plus 6 valence electrons for the oxygen. So that again is a total of 8. So again, hydrogen has to go on the outside. So we'll put oxygen in the middle, then hydrogen next to it. I'm going to bond these together with my single bonds. Then I check hydrogen's all set because it has a single bond, but oxygen only has 1, 2, 3, 4 electrons, so we need to give it 4 more. And these electrons are not bonded to anything, so those 2 electrons there, I'll circle them in red. Right there, these guys, these are called a lone pair. They're a pair of electrons that are not bonded to any other atoms. They're just with the oxygen. All right, so that's our water molecule. Our next molecule here is oxygen gas, the stuff that we breathe. So here we have 2 oxygens. So we'll say there are 2 oxygens here. In oxygen, we have 6 valence electrons. However, we have 2 oxygens, so 6 times 2 gives a total of 12 valence electrons to bond the oxygens together. Now, when we only have 2 atoms, we can just put them right next to each other. All right, so let's try a single bond here, and that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've used the 12 electrons. However, look at this oxygen right here. It only has 6 electrons, so this is a problem. It is not stable. So what we're going to do instead, we've run out of electrons, but we can make something called a double bond. So to make a double bond, we're going to have to erase these 2 electrons and move them to the space in between. So here we can use a double bond. I'm going to add another line. That is called a double bond. We have 4 electrons shared. All right, so there's our O2 molecule. Our next molecule is nitrogen. So nitrogen is made of 2 nitrogen atoms. Each nitrogen has 5 valence electrons times 2 gives us 10. So right away, you should notice, oh, well, to bond these 2 atoms together, we needed a double bond. Maybe we're going to need something even more special than a double bond for our 2 nitrogens because we only have 10 electrons. So let's try this. That's 1, 2 electrons. We single bonded them. 3, 4, 5, 6, 7, 8, 9, 10. No way that this nitrogen on the right is stable. It only has 4 electrons around itself. So let's try making a double bond and see if that works. So let's go back here and put a line there. Okay, so that's better, but this nitrogen still only has 6 electrons. So we need to get rid of yet another lone pair and move it in between here. And when we do that, we have 6 electrons shared. That is a triple bond with 6 electrons shared. All right, so there's nitrogen. It has a very strong triple bond between it. That's why it's very hard to break. And we'll go on to number 5. Now, number 5, you'll notice right away that unlike the others, number 5 has a charge. Okay, this is ammonium with a +1 charge. So let's look at the atoms in there. There's 1 nitrogen. There are 4 hydrogens. Okay, so if we add up the valence electrons, we have 5 for nitrogen plus 1 for hydrogen, but there are 4 hydrogens. However, because of this +1 charge, this means it has lost 1 electron. So we need to subtract 1 from the total count, and we get a total of 8 electrons. Again, here, looking at the atoms we have, we're going to put nitrogen in the middle, hydrogen on the outside because hydrogen is always on the outside. Let's single bond the hydrogens together. And then we're done, right? Because nitrogen has 8 around it. Each hydrogen is single bonded. Now, because this has a charge, we have to do something to indicate that this is an ion. So we have to put this in brackets, and we put the plus charge on the outside of the brackets in the upper right. All right, so that's our ammonium ion. Ammonium. All right, our next ion here is ClO-. This is the hypochlorite ion, and we have 1 chlorine and we have 1 oxygen. So here we can take 7 valence electrons for chlorine, 6 for oxygen, but again, here we've got a -1 charge. Okay, we have a -1 charge. This means it has gained 1 electron. So to this total count, we need to add 1. So we have a total of 14 electrons, 14 valence electrons to bond these 2 atoms together. So let me put the Cl here, put an oxygen here. Let me single bond these together to begin with. All right, and let's try to make chlorine stable. So we have 1, 2, 3, 4, 5, 6, 7, 8 for chlorine. Okay, so that's good. And for oxygen, 1, 2, 3, 4, 5, 6, 7, 8 for oxygen. So oxygen stable. We now need to just check that we have 14 electrons showing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have the correct number, total number, and both atoms have an octet. They both have 8 electrons around themselves. However, this is an ion, so again here, just like ammonium, we are going to put this in brackets and put the charge on the outside. All right, so number 7 is Cl2, chlorine gas. We have 2 chlorines. Each chlorine has 7 valence electrons, but there are 2, so 7 times 2 is 14. Let's put the 2 Cl's next to each other. Let's bond them together. Let's give them octets, so 1, 2, 3, 4, 5, 6, 7, 8 for this chlorine. And then let's give this chlorine an octet, like so. And let's check that we have 14 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we're all set with Cl2. All right, our next molecule is CO2, carbon dioxide. So we are familiar with this because we breathe it out. And we have 1 carbon and we have 2 oxygens. So the number of valence electrons for carbon is 4. Oxygen has 6 valence electrons, but there are 2. So that's 12 plus 4 gives a total of 16 valence electrons to bond these together. Now remember, carbon is always central. It just likes to be at the center of things, at the center of attention. So here, carbon you put in the middle and you put the 2 oxygens around it. Okay, so let's start bonding these. Let's start off by bonding this oxygen to the carbon and this oxygen to the carbon. That's 1, 2, 3, 4. Let's start trying to give octets. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this oxygen now has an octet. That's 8 electrons. If we do this, that would already, that's 8 electrons, 9, 10, 11, 12, 13, 14, 15, 16. There's no way that we can make oxygen, this oxygen, and this is not stable here. Okay, so let's try making a double bond. So let me erase these and give a double bond right here. All right, this is looking better. Now it has 6 electrons around it, but that's still not 8. All right, so let's try over here. It looks like we might be able to move these over here. So let's get rid of those electrons and give them to this oxygen. So now this oxygen has 8 and this carbon has 8, but this oxygen only has 6. So it looks like we need to make yet another double bond. So I'm going to erase these and I'm going to put a double bond, move those as a double bond. If you look here, this oxygen has 8, this carbon has 8, this oxygen has 8, and let's check if there are 16 electrons. This would be 8 plus 8. So that's a total of 16. So this is the correct structure for carbon dioxide. Okay, number 9. Okay, this is NH2Br with 1 nitrogen, 2 hydrogens, and 1 bromine. All right, so let's count up the valence electrons. For nitrogen, we have 5. Hydrogen has 1, but there are 2, so 1 times 2. And bromine has 7. So if we add these all up, 2 plus 5 is 7, plus another 7 there, that's 14. Now here, remember, hydrogens have to go on the outside, and in general, the first atom is usually the central atom. The other thing is the bromine halogens are usually on the outside. Not always, but usually. But in this case, we have nitrogen in the middle and the other atoms around it. Okay, so let's single bond the hydrogens, and they're all done. Let's single bond the nitrogen to the bromine, and now let's try to make nitrogen have 8. So nitrogen needs 2 more, right? Now it has 1, 2, 3, 4, 5, 6, 7, 8. Let's give bromine 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So bromine is now satisfied. And we want to make sure we used 14 electrons. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's our correct structure. All right, finally, this last compound. Actually, this is a nasty compound. This is formaldehyde. It's cancer causing, and people still use it for flooring, all sorts of stuff. But this is CH2O, and there is 1 carbon. There are 2 hydrogens, and there is 1 oxygen in this compound, in this molecule. For carbon, there's 4 valence electrons. Hydrogen has 1, but we're going to multiply by 2 because there's 2 hydrogens. And then plus 6. Okay, so this comes out to a total of 12 valence electrons to bond this together. So remember, carbon, center of attention, always. Put that in the middle. Hydrogens, outsider, okay, likes to be on the outside because it can only have a single bond. Oh, I should not start bonding until I've arranged all my atoms. And then oxygen, put that around the carbon as well. All right, so let's single bond these guys. Okay, so let me bond the oxygen to the carbon. And we've got, I used 1, 2, 3, 4, 5, 6. I have 6 left. So this carbon needs a couple more. Let's put 2 there. Let's try to make oxygen stable. However, that's as far as I can go. So there's a problem here. Oxygen only has 6 valence electrons. It does not have the octet. So what we need to do is take these carbon electrons, erase them, and make a double bond. Okay, so that they're shared. Now oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Carbon also has 1, 2, 3, 4, 5, 6, 7, 8. And both these hydrogens have a single bond. So this is the correct structure. Oh, I should check. Are there 12 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there are 12 electrons. So we have the correct Lewis structure. Okay, so I hope you found this video going over the homework helpful. And if you still have questions on Lewis dot structures, please ask in class. We'll be doing more of this next week and probably after Christmas break as well. There's a lot of stuff that we have to add to this to make it complete.